Thank you. Thank you. Good morning, everybody. It is such a pleasure to be here in a real room with real people. So thank you for having me here. And I have quite of a challenge this morning. I have quite of a challenge because I have 20 minutes to talk about the future of the cloud. That is, I'm going to tell you right now, you're going to have more questions at the end than answers. So just to say that disclaimer in here, this is not going to solve the future of the cloud. But before we get there, I actually would love to talk a little bit about the past, right? And what a past we had right in this room. I'm sure that all of you have been in this amazing roller coaster of the past 15 years, right? And when we see the huge transformation that the cloud has enabled, especially for digital transformation, it's just amazing, right? So do you think this is the beginning or this is the end? Well, I will use some data, right? So I'm not gonna be here telling you something. I'm gonna be here to share some data. This is a number coming, actually, I think this was coming from McKinsey. Their estimation is that in 2030, the cloud will still unlock the biggest part of the revenue, in particular for Fortune 500. So this is just the beginning. They're estimating that number to be 1 trillion. Now, the interesting thing is looking at what we've been doing the past 15 years. And this is another survey. This is asking the same companies, hey, where are you investing on the cloud? Why are you using the cloud? What are the metrics of success for your cloud implementation? And you see the pattern here, right? So cost savings, agility, cost avoidance. So it's all about optimization. Now, you go back to the previous $1 trillion number. Actually, that number, like 2/3 of that, is not on optimization. It is enabled by innovation. So if you compare the two things, clearly we're still unlocking all the potential of the cloud. That's my goal for today, is covering a little bit what are those areas of innovation in the cloud so we can get a sense, we can get our foot on that 2/3 of the unlocked potential that we have for the cloud. And a good place to get started is looking at the vision for the cloud. So what are the 3 key areas for this cloud vision, right? And we always talk about these 3, so these maybe are familiar for you. We talk about ubiquitous computing, we talk about artificial intelligence, and we talk about immersive experience as the 3 big areas of innovation for the cloud. Now, if you map that with the technologies that will enable that for the future, these are the 3 technologies that are enabling that for the future. And these are the 3 technologies that I want to cover today at least a little bit. The first one, 5G and space. That will be a dramatically transformation of the network connectivity that is enabling ubiquitous cloud. And that will create a new paradigm for connected applications. The second one, AI. So we are all, especially in the latest months, we are all about, so you have heard a lot about the concept of AI at scale, these massive models that are redefining the way that we develop and that we use AI. So we'll talk about that. But then, an expansion of that is when we will be able to do the same thing for quantum computing, when quantum will get the scalability required to get to the toughest problems that it can solve. And the third one, we will also talk about the paradigm of human and machine co-reasoning. So the first 2 will come together to enable a new paradigm for how humans and machines collaborate. So let me start with the first one, 5G and space. So obvious thing in here, you are all living this trend right now, but compute is clearly expanding to the edge. So 70%, this is another number coming from Gartner, is the percentage of the data that will be not only created, but also processed at the edge. So we're moving computing closer to where the problem is, right? And 5G will accelerate that trend. Why? Because it's not only like a network upgrade. So it's not that you will have more bandwidth, right, with a 5G connection, which you will, of course, but it's more about all the additional capabilities that it will provide, creating a new paradigm for connectivity. Super low latency, enabling new scenarios, a high scale of devices that you can connect within networks, and the ability for those devices to get network aware and to get more capabilities from that network. But then on top of that, it's not only that this compute is expanding on the Earth, but it's also going to space, right? So we're seeing huge trends in there, in particular because of the democratization of space, right? With things like low Earth orbit satellite, which are lowering the cost, that will enable not only ultra-reliable connectivity in any area in the planet, but also bringing compute to space, to satellites, bringing new capabilities like Earth analytics. So this is the core of it. Now, what this is going to create is that ultra-distributed paradigm for applications. So today, we are all about enterprise on premises. We are all about the cloud. We're going to see that expanding to the left and to the right. We're going to see first compute going to your own private 5G network. We're going to see also how compute will land in your operators. So the operator will also offer compute as an expansion of the cloud in the public 5G edge. And then all the way to the right, even space will join this ultra-distributed paradigm, so you can also use it not only for connectivity, but even for compute. So our approach for that in Microsoft is clearly unifying all of this, so you can have one application pattern that you can target in a unified way, in a simple way, right? So and we do that with two things. First, we are clearly expanding Azure. You have seen that for sure, and you will see that even more in the future, where all these computing targets can be unified in a common management platform, right? And then on the bottom of that, we are also providing this unified framework for enterprises and developers to target those transparently. So you can create this new application paradigm with easiness and productivity. So this was about the first one. Let me show you an example of this. This is Ferrovial. Ferrovial is a construction company. They build like large infrastructures. So what they did is bringing all of this technology to their highways, right? So they have full coverage in their highways for 5G, and for remote areas, they're also using satellite. And what they do is that they're able to bring, because of that, they're able to bring compute to the highway itself. That allows them, for example, to bring all the sensor data that is captured through 5G and space, and directly create, for example, AI models that are able to detect hazards in the highway. All of that is then connected to the cloud. So you have long-term analytics that you can use, for example, to create better highways with a digital twin in the cloud that engineers can use to improve or create and design new highways in the future. So let me move to the second one, AI and quantum. So AI, there's no way that I can cover everything that is going on AI right now, as you can imagine, right? But let me give you just one concept here. So all this noise that you are now listening about AI is all grounded in this concept. So because we're creating new model architectures that are able to be highly parallelized through high computing, through supercomputers in the cloud, and they can be trained on massive amounts of data, like the entire internet flow of text. What that is creating is a massive exponential increase in the complexity and the power of those models. So you see that trend that you see in there is exponential. So we're seeing how every year we're able to multiply several times the number of parameters in a model, the complexity and the power of those models. This is what we all know. Now, the interesting part here that is not so talk externally, that is not a discussion externally, is how this is enabling a new way of creating and developing AI. So in the traditional way, you usually have a domain, you have a task that you need to create a model for. So you gather a data set for that task and that domain. For example, I don't know, detecting or doing a price comparison, right? Or doing inventory optimization, whatever the task on a particular domain, like manufacturing, right? You create a data set, you train a model for that, and you apply that model for that task and that domain. You need another task or another domain, you need to do that from scratch, right? That is the traditional way of creating AI, of developing AI. With these models, what we're learning is that they are multitask and multi-domain. So yes, initially, you have to use a lot of data in a large supercomputer facility. But once you have that, you can apply that model multiple times to multiple domains and multiple tasks. So in a sense, what this is creating is a new paradigm on how we use AI, from AI being something that I have to create for every task, to AI being a platform that I can use like a traditional software platform, right? So it's not an infrastructure platform, it's a model platform. It's AI models as a platform that I can use to any task and any domain. So that's the first thing. The second thing, super interesting to understand from these models, is that not only they are multitask and multi-domain, they are multimodality. So you can use them in multiple modalities, right? So the one that we all know that is all over the press and so on is language. So the ability for these models to understand and generate language, super clear. We are also probably familiar with image generation. There's also video generation. Probably familiar also with things like a GitHub Copilot, right, with code generation and code understanding. The one that I want to explain today in more detail is the last one. Because just like these models can understand and reason over language, over the language of humans, these models can reason and understand the language of nature. And those are molecules. So a modality for these models is a graph. And a graph, so a molecule is just a graph of atoms. These models can reason on top of that. And what this will enable is an entire new transformation that we will see coming and being applied in any domain as well. And it's the transformation of really having these models reasoning on top of that language of nature. So think of the implications of new materials or drug discovery, energy, food supply, environment. All of those will be redefined with these models. And not only that, we will also see a transformation, a journey in this path, right? So we'll see how we can start today with high-performance computing. Then we can apply AI to really accelerate that approach. And then in the future, we will also be able to increase the accuracy and the scale through quantum computing. So this is, it sounds like science fiction. It is actually a reality today. So we work with many customers today. This is one of their Novartis. We're working with them to redefine their drug discovery process. Using these AI models, they can predict and they can explore molecules to, for example, find drugs for particular domains. Then the next step, quantum computing. So what are the challenges in here? So how do we make sure that we can address that domain with quantum computing? So the quantum computing that you hear today is not enough for that, I will tell you that. So the amount of scale that you need to address these challenges are far bigger than the current scope. We're talking about millions of physical qubits to be practical in one of these domains. So for that, we need to solve three problems. The first one is the stability of those qubits, right? So that's why we're so focused on our approach on the topological qubit, which is a much more stable to create those qubits. The second one is the scale. So you need to be able to create scale machine for quantum. And that, the equivalent today, you see one of the quantum machines today, they look a little bit like the vacuum tubes that we have, right, like 50 years ago. Why is that? Because you have the qubit in one side, and then you have the electronics, the traditional electronics, to control that qubit. And those live in two different worlds. One is cryogenic, the other one is in normal temperature, right? And you need to connect those with these big cables, so that doesn't scale. Our approach is to bring those together in one chip so we can really scale, just like the approach, the revolution that happened with CMOS in semiconductors. The third thing, super important too, is that we need a full stack on top of this. This is not just a CPU upgrade. I'm going to upgrade my CPU to quantum and that's it, right? This is much more complex. We need a dramatically different way of creating these applications. That's why we're also working on the full stack to enable that. So that was quantum. The third one, it's amazing that I covered quantum in 2 minutes. You have to give me some credit here, by the way. The third one that I want to discuss today is human-machine co-reasoning. Why? Because if you think, take a step back for everything that we talked today. If you combine those things, if you combine being able to bring the physical and the digital world, and then you add the ability to simulate those worlds to solve problems, and you add the human at the end of it, what you have is a new paradigm on how humans and machines collaborate. It's the concept of co-reasoning. And we are so convinced that that is going to be a huge evolution on how we use machines that will transform even the way that we refer to us, right? So right now, when we have this paradigm, of course, of the information worker, right? So humans using machines to get data and reason on top of that data. We are the ones who are reasoning. In the future, we will see the concept of intelligence worker, where humans and machines are co-reasoning together. And that can be applied to any domain, from researchers, like researching the next new molecule for a new clean energy, all the way to our traditional enterprise tasks and frontline workers who can have AI as a companion for everything that they do. So a good example of this is, this is coming from firefighters, right? So in this case, this project, what we did with them is really enabling that co-reasoning, in this case, between a machine and a firefighter for wildfires, right? So they have all this data coming from satellite, actually, with full connectivity with satellite 2 and 5G. So they have local connectivity in the middle of the wildfire. And with that, they can co-reason with AI. So they can get an understanding on what is going to happen next. So that symbiosis between machine and humans, we will see more and more in this kind of scenarios. So let me finish with one thought in here. So everything that I said today, useless. That is not the goal. So you start there, that is not the right way of looking at this, right? This is just an enabler. All the technologies that I explained today should be just an enabler for the end goal. The end goal is not just the technology for the sake of technology. The end goal should be, one, how we can create business growth with that technology, and how we can react better to disruptive change in our business with this technology. And the connection between these two, to make sure that you connect technology with that impact in the business, is really two things. It's a strategy and it's culture. Those are the two things that I would recommend everybody to address in their companies to connect those 2 points, right? The first one, the strategy, is just a common mistake, and I'm sure that you've seen this many, many times, where in our mind, we separate in our company innovation from current business, right? So we have innovation, we create a center of excellence or an innovation department, and that's it, I'm done, right? I'm super innovative because I have this team, right? The reality is that you have to connect those dots. You can't have innovation and business completely separated, right? The reason for that, the way I can share, for example, how we do it in Microsoft. In Microsoft, we use this framework. This is based in McKinsey. It's the Horizon framework. So we map our investments in Horizon, short-term, medium-term, long-term. And that's fine. That will allow you to have a balanced approach. But then the most important thing is that we connect those. So we have investments which span through horizons. So you have seen, for example, AI at scale is a great example. You have seen how we are talking about this futuristic new AI, but it's available today in Word. You can use it in Outlook. So it is being used in Bing. So it is important that you apply those long-term bets into short-term business. That's one recommendation. The second one is the culture. Is this whole concept that this is not about creating innovation department. This is about creating innovative companies. And for that, you need to change the culture of each of these layers. First, the technical departments, they have to think more of how they enable innovation in the company versus centralizing the innovation. That's recommendation number one, if you are a technical department. How can I enable the business to innovate instead of how can I take all the credit and centralize all the innovation here? The second one in the business is business accountability. The business has to be accountable for that innovation. This is not about, okay, the innovation department will do everything for me. The business has to be accountable. We have to provide incentives to the business units so they can embrace that innovation. And the third one, if we really want to transform the entire company, we need to bring every employee in. And the only way to do that is to enable that employee, is to think on how should I provide training across my entire organization on this innovation. One example that I tell all the time in Microsoft is our finance department, where we started like the top-down. We started with a centralized approach, and it didn't work because there was a huge reaction from the entire department. The other way around, it worked much better. So we provide a full training to every employee in our finance department on AI. That was the case. And that changed dramatically how the department embraced this technology. So one thought after this, I think that would be the great summary. I know that I put more questions in your head than answers, but if there's one answer that I want to give you today is, please, let's think about this technology. I know that a lot of people here, including myself, are technical people, and we tend to think about technology as an end. Let's think about it as a mean to an end, right? Let's bring people in here, because at the end of the day, it's the humans, the business, the employees, the ones that are going to be driving that innovation. So if you want more information, we even have a newsletter that you can sign it. So that's the URL. And of course, feel free to contact me LinkedIn for any question that you have. Thank you very much.